Welcome to Module 5, Lesson 2, Adding and Subtracting Decimals. Today we're going to talk about how to fluently add and subtract multi-digit decimals. Alright, so here we go. First, we're going to take a look at modeling decimal addition. So we have a chemist who combines 17 hundredths milliliters of water and 49 hundredths milliliters of hydrogen peroxide in a beaker. How much total liquid is in the beaker? So again, we're going to highlight the question. And then we are going to box important numbers because I know that I want the total. I know 49 hundredths is important and 17 hundredths. Now notice when I say my decimals, I'm talking about 25 hundredths, 17 hundredths, 49 hundredths. I'm not saying 0.17. Point is a term in geometry. We're really going to focus on saying our decimals correctly, especially since we're going to move on to converting between fractions and decimals, and knowing those place values is going to be very helpful for us down the road. Okay, so first we got to look at how many grid squares should you have to represent 17 hundredths milliliters of water and why? Well, in order to represent that, I would need 17, and again I'm going to type to make it go faster. I would need 17 grid squares because 0 and 17 hundredths means 17 out of 100, or so the way that we would look at this as a fraction would be 17 over 100. Okay, then the next question would be how many grid squares should you shade to represent 49 hundredths milliliters of hydrogen peroxide? Well, in this case, again, I would need 49 grid squares because 0 and 49 hundredths means 49 out of 100, or again, as a fraction, 49 over 100. Okay, so we're going to use the grid square to the right to model the addition. We're going to use one color for 17 hundredths milliliters and another for 49 hundredths milliliters. So if you don't have two different colors, you can shade lightly for one and then color more darkly for the other to give that differentiation. I am going to use orange for my first one, so I need to color in 17 hundredths, so 17 squares. So this is 10 by 10, so I know that I would need 10, 11, 12, 13, 14, 15, 16, 17. So that would be 17, and then now I need to color in 49 hundredths. So here I'm going to use yellow. Now to do the 49 hundredths, I am going to do 10, 20, 30, 40. But then instead of doing 9 right away, I'm going to do 3 up here, so that's 43, 45, 46, 47, 48, 49. Well, now let's take a look at this and count. How many squares do I have filled in? Well, in total, I have all of these rows of 10. So 1, 2, 3, 4, 5, 6 rows of 10. And then I have 1, 2, 3, 4, 5 extras. So I have 65 then, so 6 times 10 would be 60, plus that extra 5 would be 65, and it's 65 out of 100, and I'm sorry, 1, 2, 3, 4, 5, 6, I miscolored this one. There we go, a little further. So this would be 6, plus the extra 6 would be 66 hundredths milliliters. That's why we got to make sure to color in that full box, okay? So in this case, I want you to try to represent numbers 1 and 2 on your own. Again, you can use a light pencil shading for one and a dark one for the other. What I would like you to do, so what I'm going to say you should do is if you're going to do, so like I did 17 hundredths in orange, you can put a box around it in orange, and then I did the 49 hundredths in where it is? There it is, yellow, so I'll box it in yellow. Do the same thing for yours, and I'm going to check this in class tomorrow. All right, so on the next page, we're talking about the different steps when it comes to adding decimals. So here we're talking about Susan, who rode her bicycle 3 1/1200 miles on Monday and 4 7/10 miles on Tuesday. How many miles did she ride in all? So again, I'm going to highlight the question, how many miles did she ride in all? Well, my operation word in this case, or words, would be in all. And in all tells me that I'm going to add. And if I want to know how many miles she rode in all, because it's miles, I have to add up all of my miles. So the 3 1/1200 and the 4 7/10. My first step, and I'm going to use my handy dandy magic eraser here. My first step is going to be to align the decimal point. So like you see over here, when I set it up, I have all of my whole numbers lined up over here. Sorry, I have all my whole numbers lined up over here. And then I have my 7 and my 1 lined up because those are both in the tens place. And then I have 2 over here by itself, and I add this 0. We have to line up, when we line up our numbers to add, so like if we were doing 19 plus 6, we line up the 9 and the 6 because they're both in the ones place. When we line up to add and subtract, we have to line up by place value. Otherwise, you'd be adding, if I line it up like this, I would turn this 6 now into 60 because it's in the tens place. Same things happen with decimals. If I move this 7 over underneath the 2, now all of a sudden that became hundredths and 4 would have become tenths. So you have to make sure to line up your decimals correctly so that way you line up your place values correctly. After you line up the points, you're going to add zeros as placeholders, which we did right here. And then we're going to add from right to left. So here we did 2 plus 0 is 2, 1 plus 7 is 8, 3 plus 4 is 7, and then I bring my decimal straight down. So in this case, my answer would have been that she rode 7 82/100 miles in all. Now, we can use estimation to see that our answer is reasonable or that it makes sense. So we talked about estimation in the last class. So we can estimate and say that 3 1/1200 rounds to about 3 because we're rounding to the largest place value, which in this case would have been the ones place. And 4 70/100 rounds to 5. Okay, when I add those two things, I get 8. So my answer should have been around 8. 7 82/100 is close to 8, and since I rounded 5 up, it makes sense that my answer was a little bit larger. Okay, since 8 is close to 7 82/100, my answer is reasonable. Okay, so reflect. Why can you rewrite 4 7/10 as 4 70/100? Well, we're going to look at this in terms of fractions. 7/10. If I take this and multiply both of them by 10, this is how we make equivalent fractions, and it becomes 70/100. Aren't both of these things the same, 7/10 and 70/100? Okay, so it's the same thing with decimals. Think about money. If I have $4.70, I usually write it like this, but when I don't have the change, so let's say I just had $4, sometimes we write it like this, and sometimes we write it like this. They mean the same thing. These two zeros at the end don't add any value to it, okay? This and this are equivalent. So in this case, even though we don't see it that way, so 4 7/10 and 4 70/100 are equivalent. Adding zeros to the end after a decimal does not change the value of the number. So that would be your worded answer. Adding zeros after the decimal does not change the value of the number. Okay, why is it important to align the decimals when adding? Okay? It's incredibly important because we need to ensure that we're adding digits with the same place value. So it is important to line up decimals to be sure that we are adding numbers that are in the same place value. Because if we don't, then our answer is going to come off incorrectly. All right, what I would like you to do, make sure that you're showing your work. I'd like you to pause, and then what I'd like you to do is I'd like you to come back and check your answers. All right, in this case, I'm not going to go through all of the problems in showing my work, but I'm going to show on here that we get 0 and 69/100ths. 7 and 2 is 9, 4 and 2 is 6. I am going to show my work here though. So I have 0 and 61/100ths. And now here's my 0 in front of the decimal. My decimal, 3, 2, 9. Notice I didn't line up the 9 and the 1. I add a 0 here, and now I can add to get my answer. And I get 9, 3, 9, and 0, and I bring down the decimal. So I bring that decimal straight down after adding. Right, so I get 939 thousandths. Okay, here, 4 and 6/10, and I'd add a 0. I get 5, 2 and 6 is 8, 3 and 4 is 7. Bring my decimal straight down. I get 7 and 85/100ths. Remember when we talked about division and why it's important to line up your numbers correctly? Here we go again. If we don't line up our numbers correctly, we bring the decimal straight down. I could have accidentally put it between the 8 and the 5, and I would have gotten 78 and 5/10, which is way different from 7 and 85/100ths. Then the last one, 3 lines up with 7, and then 8 and 8. Okay, so 3 and 7 are both in the 1s, so they need to line up, which then means my 10s and my 100ths line up. Get 15, carry the 1, 11, carry the 1, 11, carry the 1, and I get 2. Bring my decimal straight down. So I got 21 and 15/100ths. All right, now we have two subtraction problems that we're going to take a look at. Okay, and I'm actually going to cover up what you see here. So pretend you didn't see it. And we're going to take a look at the steps that we need to follow. So first, align the decimal points. Okay, so it's the same thing. I apologize, we needed to do our ride. So how much taller is Rosa than Mia? So how much taller would have been my clue that I'm subtracting? Mia is 160 and 2/10 centimeters, and Rosa is 165 and 1/10 centimeters. So I line up my decimals. Okay, well, since Rosa is taller, Rosa will get listed first. And then now I have Mia, who is 160, so 1 is in the 100ths, 6 is in the 10s, so I have to line it up with the 6 that's in the 10s. 0 is in the 1s, and then 2 is in the 10s. Okay? Then my next step, add zeros as placeholders where necessary. In this case, we don't have to add any. And then I would subtract from right to left and regroup when necessary. In this case, I can't do 1 minus 2, so I borrow from the 5. It becomes 4, and the 1 becomes 11. 11 minus 2 is 9. 4 minus 0 is 4. And then 6 minus 6 is 0. 1 minus 1 is 0, and I bring my decimal straight down. Okay, now again, I can check my answer for reasonableness by estimating. But I know here that Rosa is 4 and 9/10 centimeters taller than Mia. And then to check for reasonableness, I would round the 165 and 1/10 to 165. I could round the 160 and 2/10 to 160. And then I know that my answer should be close to 5, which 4 and 9/10 is very close to 5. Okay, in this case, we rounded to 165 because we only had after the tenths place here. So we can make our estimate closer. With the smaller place value, we can make our estimate closer. If we would have rounded all the way to the hundreds, our estimate would not have been nearly as close. Okay, then again, step 1 would have been to align my decimals. Now in this case, add zeros as placeholders when necessary. So since we're trying to figure out how much further did Matthew throw the discus, how much farther? 0. One threw it 58 7/10 meters, and the other threw it 56 12/100 meters. So now in this case, I did have to add a 0. Okay, so I had 58 and 70, and I had 7/10. So I'm adding that 0. Got a little ahead of myself, and I'm subtracting 56 and 12/100. So I'm adding a 0 here as a placeholder so I can subtract correctly. Okay, and then I know step 3 is to subtract from left to right and regroup if I need to. 10 minus 2 is 8. 6 minus 1 is 5. 8 minus 6 is 2. 5 minus 5 is 0. Bring down the decimal and I get 2. So I know that Matthew throws the discus 2 58/100 meters further than Zachary. All right. That is it for this lesson. You guys have your guided practice. Again, obviously you can't show 1 and 2 on here, so you have 4 problems like this to do tonight, and then the rest of these will all be listed on your guided practice online. As always, if you have any questions, please be sure to email me or write them down so we can go over them in class.